Okay, one of the things we look at in combinatorics a lot is permutations, and a permutation is like an arrangement of a set. Basically, if you have a set of things, like for example, let's say we have the set ABCD. Then a permutation of ABCD is basically a string that you form using one copy of each of the elements from ABCD. So it's like an arrangement, an ordering, if you will, of those things. So one possible permutation would be ABCD. Another one would be like ABDC. That's a different one, right? And then maybe you could do like ACBD and ACDB, like that. And those would be all different permutations, and then we could start like rearranging them even further, and ... There's lots of different possible permutations of the set ABCD. So another way to think about that is basically as like a mapping. You have this set of elements in the set. Let's call that the set A there. And you're basically mapping those elements to positions. Position 1, 2, 3, 4, right? 1, 2, 3, 4. You have these 4 positions that you're mapping them to. And so essentially it's just a bijection between the set A and the set 1, 2, 3, 4. And so in general, if you want to make a permutation of the elements of a set, you can just that's just like saying let's just form a bijection between the set and the set 1 through n, where n is the number of elements. Okay, so this you can only do this with a finite. Well, actually, yeah, it makes most sense to do this with a finite set. I guess technically you could do this with an infinite set as well. But we're not going to do it. We're not going to do that. So what I want to talk about is how to count the number of different possible permutations. And the thing we're going to use to count permutations is the factorial operation. You may be familiar with this factorial operation. It's the exclamation point. And if you have a set A of cardinality n, the number of different permutations of that set is going to be counted by n factorial, which is n times n minus 1 times n minus 2 ... all the way down to times 1. So let's say, just as a proof, let's essentially say that this is going to be a proof. I'll put proof in quotes because this is not quite a proof, but I just want to kind of explain why it is that this is true. So say you have like n blanks, and you've got n elements. You have this collection of n elements. You got this bin over here. Here's your bin, and here you've got the n elements like A1, A2, A3, ... all the way up to AN. And these things are just sitting in this bin. You can grab them and put them somewhere, and you can put the elements in the blanks. And what you would do is say, well, I have n things in my bin here, so I'm going to take one of them and I'm going to choose one of them to put in the first blank. And I have, so I'm going to put something in that blank. So let's take this one and put it in there. And now this one's going to be gone, like I've used it. There are n different options for which element you put in the first blank. But now that we've used it up, it's gone. And now the number of options for what goes in the second blank is n minus 1. Okay? There's n minus 1 different ways to fill that second blank. And so if we grab one of these and put it in that second blank, then now it's gone. We've used it up. And now we only have n minus 2 different options for an element to put in the third blank, and so on. N minus 3, ... until we get down to we have 2 options. And then for the last blank, since we have n elements and n blanks, the last blank, there's only going to be 1 element left. And so we're going to take that last element out of the bin, and we're going to put it here in the last blank, and there's going to be only 1 option. So now we would use the multiplication rule and view this as a sequence of tasks. Select an element for the first blank, and then select an element for the second blank, and then select an element for the third blank. And the multiplication rule says the number of ways to do all of these steps in the procedure is to multiply the number of ways to do each one together. So we do n times n minus 1 times n minus 2, ... all the way down to times n. And that's how you get this n factorial idea, right? So it's just multiplying the number of ways, number of different options for what element goes in each blank. And then you reduce the element by 1 each time because you're using them up as you go. So, okay, so now that we've introduced that, now I want to go over this example. I actually kind of want to treat this like an exercise. So you might want to pause the video and try this on your own. All right. The setup is this. We have a wedding party. And this particular wedding party consists of a bride, which we can represent by the letter B, a groom, which we'll represent by the letter G, and then 4 attendants who don't need to be named. There's 4 other people, right? Like wedding